Hello students, welcome back to video series on chapter 3. Last slide. This is an important slide in terms of this chapter. There's some really good review questions and test questions based on the this material, where it is a test of independence. We can test or determine if two events are independent. If we take the probabilities of those two events and multiply them together, they should equal what we have noted in real observations. So remember that two events are independent if this formula here holds out. If this formula here holds out. Probability of A times the probability of B equals the probability of A given B. We're going to go over an example on page 48, determining if candy color and type are independent by using red and Smarties as our characteristics. So we're going to take the data from here. Red candies, a total of 14 out of 25, and Smarties, a total of 13 out of 25. So this information here that I'm going to give to you in red, this is basically from the table. So this is given to you. The probability of a red candy equals 14 out of 25. We're going to change that to a percent as well. That's 56%. The probability of a Smartie is 13 out of 25. And that corresponds to a probability of 52%. And then the probability of red and Smartie, this is something we find in the table as well. Red and Smarties is 6. Right in here, this number here, 6 out of 25. Go back in here and write this down. 6 out of 25, which equals 24%. So this information here given to you from the table. The only way to determine if two events are independent is we need to know the individual or the marginal probabilities, as well as we need to know the joint or intersection probability. So that information has to be given to you. We know two events are independent if we multiply them together, and instead of using A's and B's, I'm going to be using the letters we have denoted in this example. So the probability of red candy and Smarties candy, if we multiply them together, if they're independent, they will equal what we have observed. So red candy is 56% times the Smartie is 52%. This is what we have observed in our real life situation. Does that equal, big question mark, does that equal 24%? These probabilities on the left side, multiplying those together, we get 29.12%. Does that equal 24%? And the answer is no, they are not equal. So basically, we can write in here that they are not equal, therefore they are not independent. If they're not independent, there's some factor of dependency in terms of the type of color depends on the type of candy, or vice versa. So we'll look at one other example of this. We can look at our candy table. There's 6 different interior numbers, so basically there's 6 different tests we can do. I will choose yellow as my color, so there's 6 yellow candies, and I will choose M&Ms, given that there's 12 M&Ms. And we'll do the same test to see if candy color and candy type are independent. So let's erase this. And let's go here. We have, let's do that. We have probability of a yellow candy is given to us as 6 out of 25. We're going to change that to percent. It's 24%. the probability of an M&M is 12 out of 25, and that is 48%. And then the probability of a yellow candy and an M&M, basically that in simpler terms would be just a yellow M&M. We know from the data that there is 2 out of 25, which gives us 8%. So let's look at the data again. There's 2 yellow M&Ms. So probability of the intersection of yellow and M&Ms, 2 out of 25. So we can go back here. Once again, this information here, this is given to you. Or you should be able to find this from the table in your review questions, or it has to be given to you as part of the data in the question. Now, 2 events are independent. Once again, if we can multiply the marginal probabilities together, does that equal big question mark, the probability of yellow M&Ms? So 24% times 48%, does that equal big question mark 8%? 24 times 48 gives us about 11.52%, does not equal 8%. So once again, because the left side is not equal to the right side, they're not equal, and therefore they are not independent. If you were to do this test for the other combinations of color and candy type, you'll get the same answer as not being independent. So that is the process to test if 2 things are independent. We can assume the multiplication rule right in here, but then we look at the actual numbers we get from the table or the question, the data in the question, and we solve this out because they're not equal, not independent. So that is the end of chapter 3.